Hello students, Namaskar. In the chapter Matrices, all of the topics are over. Now some of the different type of examples will be taking, as we are given some of the miscellaneous examples or miscellaneous questions of the chapter. So in this process I am taking the first example, that is a question of matrix to be done using principle of mathematical induction. So what is the question? You can see we have some more questions here in this chapter which are to be done using principle of mathematical induction. You can see, for a matrix A is equal to this, show that this is equal to this, where n belongs to set of natural numbers and I is an identity matrix of the same order 2. So for this, to show this, students will be using principle of mathematical induction. Okay, how will be using? For this you need to remember what is principle of mathematical induction and how do we prove a statement including a natural number using principle of mathematical induction. So you must be knowing what is a principle of mathematical induction and how do we prove a statement using principle of mathematical induction. Here I go and I prove this using principle of mathematical induction. So the solution for this particular question is, dear students, first of all the given statement is this. So I am first writing, let the given statement be Pn. I have named this particular statement as Pn. So what is Pn here? The given statement, it is ai plus ba whole raised to the power n is equal to a raised to the power n times I plus n times a raised to the power n minus 1 times b times a. Okay, now this capital A is this particular square matrix, small a and small b are some scalars, and this n is obviously belonging to the set of natural numbers. Okay, now as you all know that we solve a statement using principle of mathematical induction in 3 steps, and the first step is we check whether P1 is true or not. So finding P1, students, and when we find P1, what is LHS of P1? The LHS of P1 is ai, small ai plus ba whole raised to the power n, the value of 1, if n is 1, as I am finding P1. So this is the simplest form of LHS of P1. Now RHS of P1, the RHS of P1 is putting the value of n is equal to 1, so we get ai, okay, plus the value of n is equal to 1, and plus if you are putting n is equal to 1 here, 1 minus 1 is equal to 0, so a raised to the power 0 is equal to 1. So what is remaining here? BA is what is remaining. You can see for P1 LHS is equal to RHS, so you can write for P1 LHS is equal to RHS, that implies that P1 is true. Students, the first step of this particular principle of mathematical induction we have done, and what is the first step? We are checking whether P1 is true or not. So yes, P1 is true here, so now we can move on. After this, after P1 is true, what is the next step, students? The next step is, if here I am writing step second, what is, if Pm implies that Pm plus 1 is true, if Pm implies that Pm plus 1 is true, then principle of mathematical induction says that our given statement is true. So now we'll check whether Pm implies that Pm plus 1 is true or not. So here I am supposing let Pm be true. So the statement PM is AI plus BA whole raised to the power m is equal to A raised to the power m times I plus m times A raised to the power m minus 1 BA. This is actually PM, students. Now if this PM implies that PM plus 1 is true, then using principle of mathematical induction we can say that the given statement is true. Students, now I am finding PM plus 1. What is PM plus 1, students? PM plus 1 is LHS of PM plus 1 I am finding. The LHS of PM plus 1 is AI plus BA whole raised to the power m plus 1. Now that is equal to AI plus BA raised to the power m times AI plus BA. Okay, so from equation number first I can put the value of PM here. The value of PM from equation number first I am putting the value of this. Okay, so what is this? Means I am using PM here. Okay, so what is the value of this? The value of this is A raised to the power m I plus m times A raised to the power m minus 1 BA. Okay, and whole times AI plus BA. Now students, will simplify this, and when we simplify, the first step will be multiplied by first step. So we will be getting A raised to the power m times A. Okay, time A raised to the power m times A is equal to A raised to the power m plus 1. I times I, so I can write here I squared. Okay, then plus this multiplied by this one, so it is A raised to the power m times B, and it is I times A. Okay, the next step plus this step multiplied by this one, so it is m times A raised to the power m minus 1 multiplied by A is equal to A raised to the power m, and times B and times A multiplied by I. Okay, and then this particular will be multiplied by this one, so plus m times A raised to the power m minus 1, so it is A raised to the power m minus 1. Okay, B multiplied by B is equal to B squared, it is B squared, and it is A times A, it is A squared. So this is what we have got, students. Now we have to prove this is equal to PM plus 1, RHS of PM plus 1. This is actually LHS of PM plus 1 going on. LHS of PM plus 1 is going on. So now this we have to prove equal to RHS. So see, first of all, if I put the value of I square, dear students, I is 1001, and if that is multiplied by 1001, we do get, see, this multiplied by this one is equal to 1 only, this multiplied by this one is equal to 0, as 1 multiplied by 0, 0 multiplied by 1, next this is 0, and eventually this is 1. So the value of I square is equal to I only, I. So we have got A raised to the power m plus 1 and times I. Okay, so the first term we have got of this one. Now the next term we need to get is, what is RHS of PM plus 1? It should be m plus 1 times A raised to the power m plus 1 minus 1 is equal to m only, B and A. This should be our next term. So here we go, we have plus A raised to the power m B, IA is equal to A only. Okay, plus this side we have m A raised to the power m B, and then AI is equal to A only, and plus this side we have m A raised to the power m minus 1 B squared, and the value of A squared. Now we have to find the value of A squared here, students, and if I find the value of A squared, so for A as 0 1 0 0, I am finding A squared. So this 0 1 0 0 multiply by 0 1 0 0. If I do this, so multiply, the first term is 0, okay, the second term is also 0, the third term is obviously 0, and the fourth term is also 0. So for a, the value of a square is equal to 0, so we can put the value of this one is equal to a 0 matrix actually, and a 0 matrix multiplied by this one is equal to entirely 0. Okay, so I have put the value of this one is equal to 0. I can put the value of this one is equal to, so here I am writing is equal to, now what is the next step? A raised to the power m plus 1, a raised to the power m plus 1 times I plus, these two steps are remaining, students, and from these two steps, if I do take a raised to the power m b a common, a raised to the power m b and a if I take common, what would I be getting here? M plus 1 or 1 plus m? M plus 1 is what is remaining, and that is equal to a raised to the power m plus 1 times I is equal to, will be getting m plus 1 if I am writing in starting, so this is plus m plus 1 times a raised to the power m times b times a, and this is actually, students, RHS of pm plus 1. This is only RHS of pm plus 1. I am showing, see, if this is pm and if you are replacing m by m plus 1, so a raised to the power m plus 1 times I, a raised to the power m plus 1 times I. In place of m will be writing m plus 1, so m plus 1, and if you write here m plus 1, so a raised to the power m will be remaining a raised to the power m, b as b only and a as a only. So this is actually RHS of pm plus 1. We took LHS of pm plus 1, we used pm here, as I put the value of pm, this here using pm, so we used pm here and got RHS of pm plus 1. So what implied pm plus 1 is true? Pm has implied that pm plus 1 is true. So eventually after this one you can write, since pm implies that pm plus 1 is true, therefore by the principle of mathematical induction, the given statement Pn is true, and that is what we have to prove, students, that the given statement is true. And this is how we have used principle of mathematical induction to prove the given statement true. How did we do it? First of all, we proved that P1 is, whether P1 is right or not, we checked, we got P1 right, and then we used P1 Pm to get Pm plus 1 is true. See, we supposed let Pm be true, and then we took LHS of Pm plus 1, put the value of this one here, means we used Pm here, and we got it equal to RHS of Pm plus 1. So Pm has implied that Pm plus 1 is true, therefore by principle of mathematical induction the given statement is true. So student, the question was from the chapter Matrices, and what has been used here to show that this is right? Principle of mathematical induction has been used. I hope you all have studied principle of mathematical induction chapter properly in class 11, then you can easily understand it. Thank you.